Hi everybody, and welcome to the video for Unit 7, Lesson 3, which is all about something called slope fields. Now we have 3 learning targets for today. The first learning target is I can graph a slope field. So I'm going to be asking you to make some graphs today. The second learning target is I can graph a particular solution to a differential equation on a slope field. So once we have the graph of something called a slope field, which we're going to learn how to do, we are going to use that to find particular solutions of differential equations. Again, as a reminder, whenever I ask you to find the particular solution for a differential equation, what I'm really asking you to do is find the original equation The last learning target of today is I can match a differential equation with a slope field. So it's literally going to be all about looking at an equation and seeing if we can find a graph that matches with it. And the graph is going to be one of a slope field, which is the new thing we're learning how to make today. So since everything today is really centered around slope fields, let's talk about what a slope field is. A slope field is a graph that helps us to visualize the solution to a differential equation. Now, in our previous lessons, we've learned how to find solutions to differential equations, which means finding the original equation algebraically. Today, we're going to learn how to visualize those solutions. Now, remember, the solution to a differential equation is just the original equation. So we are still having the same goal. We're going to be looking for the original equation when we know the derivative. But this time, instead of doing that algebraically, we're going to be finding that by using a graph. Here's how we make a slope field. There are 2 steps. Number 1, so we're going to substitute in x and y coordinates of ordered pairs into the differential equation. Now remember, the differential equation tells us the slope of the graph. So when we plug in our x's and our y's, it tells us what the slope of the graph would be at that point. Then we're going to graph a little tiny piece of a line that has the slope that you calculated in step 1. Let's go ahead and try that. So let's consider the differential equation dy over dx equals x divided by y. In other words, whenever you want to know the slope, you take the x value divided by the y value, and it tells you the slope at that point. In order to draw a slope field, which is our first learning target, one of the things you're going to be given is the differential equation, and the second thing you're going to be given is a graph like this where there's a bunch of dots or points on the graph. You are going to graph a little tiny slope at each of the places on the graph that actually has a point identified. In other words, and I just want to point this out, we're not going to graph any slopes here. And the reason we're not is that there are no actual dots on the graph along the x-axis. We're not going to graph any slopes here either because there are no actual dots or points on the graph along that part of the y-axis. We're only going to graph little tiny slopes at each of the places on the graph that actually has a dot or a point. The best way to do this is to be organized and systematic and take your time because you don't want to run the risk of getting this wrong because of an incorrect calculation or computation. So let's start in the upper left-hand corner. So I'm going to start with this point right here. Now on the graph, the x coordinate of that point and the y coordinate of that point can be found by just looking at the graph. And what we're going to do is calculate dy over dx for each of those x and y coordinates. So let's go ahead and get started, and we're just going to be organized and systematic. This is going to take a minute, but again, the more organized and systematic you are, the less likely you are to make a silly computation error or mistake. So in this point, the upper left-hand corner, the x is -2 and the y is +2. So if I find the slope, which I know from my instructions is x divided by y, I get -1. I'm just going to move down this first column. So the next point would be the x is -2 and the y is +1. X divided by y would be -2. The next point would be -2, -1. X divided by y is +2. Then I would have -2, -2. When I divide, I get 1. That is sort of the first column on this graph. The second column, I'm going to have x is -1 and y is 2, so the slope is -1/2. Then I'm going to have x is -1, y is 1, so the slope is -1. -1, -1 is +1, and -1, -2 is +1/2. That's the second column. Now the third column on the graph only has 2 points. It's the point where x is 0 and y is 2, the slope would be 0, and x is 0, y is 1, the slope would still be 0. That's the third column. Now I'm not done yet. I still have 2 more columns. So I'm going to have x, y, and then the slope. Now this graph has a lot of points that we need to calculate. Most of the graphs you're going to be asked to do not have this many points, but I wanted to use this as an example so you can see kind of a variety of ways we have to graph here. In the next column, x is 1 and y is 2, the slope is 1/2. Then x is 1, y is 1, the slope is 1 when you divide. Then x is 1, y is -1, and then that means when you divide you get -1, and then x is 1, y is -2, so you get -1/2. And the last column, x is 2, y is 2, the slope is 1. X is 2, y is 1, the slope is 2. X is 2, y is -1, slope is -2. And then x is 2, y is -2, slope is -1. Once you've got all your slopes calculated, you just need to graph them. Now, the most important thing to pay attention to here is whether you have a positive or a negative slope. I just, as a reminder, want to remind you that a positive slope is going to be going uphill from left to right. A negative slope would be going downhill from left to right. A slope that does not exist. So for example, if one of these points I evaluated, I had like a number divided by 0, I would get does not exist. It's kind of like having a vertical line. So your slope would go straight up and down. And if one of the slopes that I calculated was 0, it would be a horizontal line. Slopes would go left and right. So the first slope at that first point was -1. So I'm going to draw a little -1 slope. Then I have -2, a little bit steeper, but still negative, just like this. Then I'm going to have +2, and then I'm going to have +1. A little less steep, but positive. In the next column, I'm going to have a negative slope. Now, -1/2 is going to be a little less steep than before, more like this. You can imagine on the graph it would be like going down 1 and then over 2. So if you imagine drawing a little tiny line that connected to this point, you're just drawing a little piece of that line. It's one of the ways I try to visualize how steep to make it. Then we're going to have -1, which looks like this. And then we're going to have +1 and then +1/2. So like this. Then we're going to have a slope that's 0 for both of these. Then we're going to have a slope that's +1/2, +1, -1, -1/2. And then we're going to have a slope that is +1, +2, -2, -1. And that would be my slope. Now, the second thing and the second learning target is, I guess before we do this, what this is helping me do is visualize what the original graph would have looked like. But it's giving me a visual of like sort of just the shape of the graph. It's not giving me a specific graph of a specific function that goes through these points. The next part of the question is going to ask me to graph the particular solution that goes through the point 0, 1. Now, when you look at the graph you drew, this is the shape of the graph. It doesn't tell me the shape of a specific function. Remember how the C could be anything? There could be lots of different answers depending on your C value. This sort of gives you the general shape of all the answers. If you want the solution that goes through 0, 1, you're going to go to the point on the graph right here and use that point as a guide to sort of follow the shape of the graph and draw the particular solution you were looking for. Here's how you do that. This point in the middle has a horizontal slope. So from here, I'm going to go straight out to the sides a little bit. By the time I get to the first column to the right, the slope is a little bit more positive. So I'm going to make my curve turn up. And then going out towards the edge, it keeps going up. So I'm going to make my curve turn up. If I go left, I'm going to make my curve turn up as I go to the left and then keep turning up as I go to the left. So the particular solution looks kind of like a parabola. Next, The last part of the learning target for today, and I'm going to zoom out a little bit here so that we can actually see all of this at once, is to match the slope field with a possible solution. Remember, a slope field just shows us a general shape of the original function. That means that we can use a slope field to say which of these original functions makes sense. Here's how, this is the strategy that I use to figure this out. I know that a cosine function looks like this. In a cosine graph, it starts high, and then it goes middle, and then it goes high, low, and then high. So if I'm looking for a graph that has that general shape, it sort of has a flat spot near the x-axis, and then it has a negative slope, a flat spot somewhere around here, and then a positive slope, and then a flat spot somewhere around here. If I look here, I can see that the only graph that has a flat spot, goes downhill, and then comes back uphill would be number 5. So I think 5 is A, the cosine function. Y equals e to the x is going to be a graph that generally has this shape. Now I know that the only graph here that generally has that shape is the graph for number 4. So I'm going to say that that means number 4 goes with B. For y equals e to the negative x, I'm just going to take the shape of that graph and flip it horizontally because the x is negative. So the shape would look like this, which means I'm going to say that 6 is C. And negative cosine is a graph that's going to start low and then go up and then go down and then go over. It's just the vertical flip of the part A graph. So I'm going to say that that goes with D. Again, you're just sort of visualizing the shape here. This graph looks like an e to the x graph. This graph looks like, if you drew like one particular solution, it looks like an e to the negative x. This graph right here, if you drew one particular solution, looks like a cosine. And this graph right here, if you drew one particular solution, looks like a negative cosine. I just want to point out that this is showing me all the possible solutions depending on C. And I'm just saying, in general, the shape of this graph would be either A, B, C, or D here for the answer choices. All right, that is it for today's video. Thank you guys so much for watching, and I'll see you soon for some practice.